friends, we just finished up the different types of angles and how you classify them by angles and sides. And then we're going to do a theorem that many of you have known before, but you didn't have the formal name. It's called the triangle angle sum theorem. Now, think about the name, triangle angle. So we have the angles of a triangle. The sum means they're added together. So we're going to talk about what their sum is. And the triangle angle sum theorem is the following. The sum of the measures of the angles of a triangle is 180 degrees. It's kind of the magical number, 180 is. You know, a linear pair has the sum of 180 degrees. Supplementary angles have the sum of 180 degrees. So it works out pretty good. So let's just zoom in a little bit on this. And we get the fact that if I have a triangle, I know the measure of angle A plus the measure of angle B plus the measure of angle C is always 180 degrees. Now, how do we get that from just a basic diagram like this? Well, we use what's called an auxiliary. I'm going to use the fact that I can draw a line through point B that's going to be parallel to AC, because remember, in geometry we have an infinite set of points everywhere. So I know I can draw a line that has that goes through point B that's parallel to segment AC. Now I'm going to actually use what I know about parallel lines, because remember, the instant I tell you the word parallel, you should start thinking alternate interior angles being congruent, corresponding angles being congruent, and same side interior angles being supplementary. Anyway, so here's how we're going to show it. Somehow I need to show these three angles add up to 180 degrees. Well, here's how we can go about it. It's really easy. If I have the fact of parallel lines, segment AB becomes a transversal. I know then that I have a pair of alternate interior angles are congruent. Then I also know that segment BC is a transversal. And I have another pair of alternate interior angles that are congruent. Now, knowing that, what do these three angles right here add up to? Well, they add up to 180 degrees because the sum of the parts equal the whole. So it's 180. But if those three angles add together to 180, what does that mean these three have to do? Because they're all the same size. They add up to 180 degrees. Really cool, isn't it? So really, why is this the reason? Because of parallel lines and sum of the parts equal the whole. Kind of cool, isn't it? Now, here is an example that we're going to use applying this. This is one of the most common sense and pretty simple ideas. But when I'm working with this, I just start putting everything I know in. So here I have my three angles, A, B, and C, or angle 1 and 35 degrees and 65 degrees. What do I know about them? They all add up to what? 180. So I literally can say the measure of angle 1 plus 35 plus 65 is equal to 180. So I know this is going to be 100 degrees equals 180. Subtract 100. The measure of angle 1 equals 80 degrees. Now, I've had people say, Mrs. Gregerson, can I just do this? The measure of angle 1 is 180 minus 100. Yes, as long as you show me the work and you get the same answer, I am okay with that. This one's more of the algebraic approach and applying the theorem very specifically, saying the sum of the measures of the angles all add up to 180. So it's an easy way of doing that. So it's not a bad approach, but if you understand it well enough, does this still work? Yeah, it still works. So that's the cool part about it. Exterior, and these two angles are remote interior angles. Now, because of this magic number of 180 degrees, we have this really cool way of finding angle measurements without having to use all three angles of a triangle. First of all, this is the measure of each exterior angle. And by the way, to form an exterior angle, you just extend it one time. You don't extend both sides. You just extend one. Of a triangle equals the sum of the measures of its two remote interior angles. I'm trying to figure out where's the best place to put this. I think we're going to do it right here. Two of its remote interior angles right here. So it's the sum of those two. Now, which ones am I talking about? What I'm saying here is this exterior angle, okay, is the sum of angle 2 and angle 3, the ones that are farthest away. Now, how does this work? And let me actually put numbers in. I think it'll make a little more sense. Let's say, for instance, this angle was, let's say, 60 degrees, and this angle over here was 40 degrees. Because I know the three angles, the remote interior angles of a triangle add up to 180, I know that this angle would have to be 80 degrees. Because these two are a linear pair, they're supplementary, and they add up to what? That's right, 180 degrees, which leaves this one, as my pin rolls across, to be 100 degrees. Now, what does angle 2 and angle 3 add up to? 100 degrees. So yeah, basically why? It's because of the triangle angle sum theorem and the linear pair postulate. Because we know, because these add up to 180 and these add up to 180, have that magic number that works. This is just a time saver. That's all it really is for solving for the missing angles. So here's a couple examples of doing this and applying this. First of all, here we have a 30 degree and a 40 degree angle, and these are our remote interior angles. Notice the exterior angle is being formed. So those are my remote interior. This one's my exterior, right? So I know the measure of angle 1 is 30 plus 40 degrees, which is 70 degrees. Now, I've had people say, I don't see this. I don't understand how you get this. There's more than one way of solving this. I could use the fact that these three angles add up to 180, correct? And that means the missing one here is 110. Then could I use the fact that this is a linear pair? So I could go ahead and say then the measure of angle 1 is 180 minus 110. It's 70 degrees. Right. So that's kind of one idea. Now here's another idea that saves time. But again, there's more than one way. But I like the exterior angle theorem because I know it, I can apply it quickly. I still know that these two are my remote interiors. Remember, this is my other interior and it's right next to it, so it doesn't work. But these two I know add up to my exterior. So all I have to do is measure angle 2 plus 7 equals 113 degrees. So I subtract 70. So the measure of angle 2 is going to equal 43 degrees. Now, that's one way of doing it. Or I can use the fact I have the triangle angle sum theorem and a linear pair. These two are a linear pair because remember they form this line. So what is 180 minus 113? That should be 67 degrees, okay? So I have 67 degrees. Well, what do the angles of the triangle add up to? 180. So I can say the measure of angle 2 plus 67 plus 70 equals 180. So I have 137 degrees equals 180, right? The measure of angle 2 plus 137 equals 180. Subtract 137. I still get 43 degrees. Notice the difference is I actually have to mark more things in my diagram. And here's the thing. If in doubt, start putting in everything that you know. All right, now we're going to go work on some examples together to apply these.